Okay, let's talk about the invisible engines that power your entire digital world. They're called databases. And honestly, without these unsung heroes, pretty much all the apps and services you use every single day just, well, they wouldn't exist.
And I'm not exaggerating. Think about your morning today. The second you shut off your alarm on your phone, check the weather, or mindlessly scrolled through your social feed, yep, you were talking to a database. They are so deeply woven into our lives that we don't even see them anymore.
So let's pull back the curtain a little bit and see just how often you're tapping into these incredibly powerful systems, probably without even realizing it.
I mean, really think about it. Every time you scan your loyalty card at the grocery store, bam, a database just logged your purchase and applied a discount. Ordering a pizza? A database is holding onto your order, your address, your payment info. Every single product you see when you're browsing online, it's all being pulled in real time from a massive database.
All right, so they're everywhere. We've established that. But what in the world is a database, really? At its heart, it's just a really organized collection of information. But the real magic, the secret sauce, isn't just the data itself. It's all about how that data is structured. And this is the crucial part, how all the different pieces of information relate to each other.
So a diagram like this, it's called a schema, is basically the blueprint for all those relationships. You can see how one box, let's say your order, is linked to another box that contains the items in that order, and that box in turn links to product information. It's this interconnected web that lets an e-commerce site instantly show you a complete history of everything you bought, when you bought it, and for how much. It's incredibly powerful.
And here's the thing, we don't access this data directly. When you use an app, you're the user. The app itself talks to something called the Database Management System, or DBMS. The DBMS is kind of like the Librarian. It's the software that actually goes and finds, fetches, and updates the information in the database for the app. It does all the heavy lifting for us.
Okay, so this is the main idea I really want you to take away from this. Not all databases are built to do the same job. In fact, it's really helpful to think of them as having two totally different personalities. Just imagine a bank, right? You've got the teller at the window who needs to handle your deposit right now, fast and accurately. That's one job. Then you have the financial analyst, way back at headquarters, who needs to look at all the transactions from the entire last year to spot trends. See? It's the same data, but for completely different jobs. And databases are specialized for these two roles.
And this table just lays it all out perfectly. On one side, you have the transactional systems, also known as OLTP. They're the bank tellers. Their entire goal is to run the business with super fast, simple questions about what's happening right now. On the other side, you have analytical systems, or OLAP. They're the analysts. Their goal is to analyze the business using slow, really complex questions on huge piles of historical data.
And hey, don't just take my word for it. This quote from a developer on Reddit just hits the nail on the head. They're saying this isn't just some academic idea, it's a critical business need. You absolutely do not want the analyst's massive, complex query to slow down the tellers who are trying to help customers. If they were using the same system, your checkout page could just grind to a halt. And that's exactly why companies create what's called a read replica, a totally separate copy of the data just for analysis so they can protect the live operational system.
So let's zoom in on that first personality, the transactional workhorse, the one that keeps the lights on and everything moving.
These are the systems you're bumping into dozens of times a day. Every time you click Buy Now, or pull cash from an ATM, or book a flight online, you're using a transactional database. Each one of those actions is a tiny, self-contained transaction.
So the whole point here, the reason these things exist, is that they're optimized for pure speed and rock-solid reliability. They have to be able to handle thousands, sometimes even millions, of little updates and reads all happening at the exact same time, and they have to do it without breaking a sweat. This is literally what keeps a business running, day in and day out.
Okay, now for the other personality, the analytical strategist. This one is all about stepping back and seeing the big picture. An analytical database is what creates reports that look like this. Now, it might look like a simple spreadsheet, but it's so much more. It's actually a multi-dimensional view of the data. This is what lets a manager slice and dice all that information to see which products are selling best, in which cities, and to which customers. It helps them spot trends that would otherwise be completely invisible.
This is where you get all the cool stuff. You know, business intelligence dashboards that show the health of a company at a glance, or things like market basket analysis. That's what led to the famous discovery that people who buy diapers on a Friday night often buy beer too. No way you'd find that out without analyzing huge amounts of past data.
But of course, databases aren't just sitting still. They've been evolving for decades, constantly changing to keep up with our crazy changing world.
You know, in the early days, we had these really complex network models. Then, the 80s came along, and the superstructured relational model just took over and dominated for decades. But today, that superstructured approach, well, it kind of struggles with all the messy, unstructured data from the internet, things like images and videos and social media posts. And that's why we're seeing all these new approaches, like NoSQL and cloud databases, popping up to tackle these massive modern data challenges.
And that really leaves us for the final thought to chew on. I mean, from simple paper ledgers to the incredibly complex systems that are running global AI today, databases have always adapted. So as our data just gets infinitely more complex, the real question isn't if they'll evolve again, but into what? Beyond the teller and the analyst, what new personalities are going to emerge to manage the information of tomorrow?